Hello, everybody. Beaming from the UK. It's ridiculously early in the morning here. Hopefully, it's nice. It's also winter and dark and cold. Hopefully, it's nice and summery where you are. It's lovely to see you all, although I can't quite see you. I'm imagining seeing you all. I was there in Australia a couple of years ago and a year before. Oh, that was last year, wasn't it? So I've some vague understanding of what it's like to be over there. But anyway, I'm here today to spend a bit of time with you to talk to you about a system I've developed, a programming language and environment that has some, I think, quite interesting properties, because it's not really a tool for teaching you how to become a professional programmer that's going to allow you to build business apps, although you can use it in that way. It's actually a tool to allow you to use code and to learn the basics of programming in order to express yourself, in order to make music, in this case, and to share your thoughts that are in your brain, maybe that were hard to come out. And sometimes one way to get those thoughts out is to write a poem or paint a picture or do a dance. But actually, there's other things which those things can't express, and code actually becomes a really powerful tool for being able to express a new set of things in our heads and minds. And I think it's really exciting to explore that. I can even imagine a time before we could, as a society, read and write, how difficult it would have been to express many things that we now find very easily, because we can just write our thoughts down, or write a poem, or write a diary entry, and or write a letter to our friend. I think there are those kinds of things waiting to be discovered inside code that we could use to help us to become more expressive. And I think that, the root of all I'm going to do and show you in the next hour or so is about, the frame of that, why I've been working on this project is really about dealing with the challenge of teaching children how to code. And certainly in the UK, and I think it's happening also in Australia and all over the world, is the governments and societies are starting to decide that teaching programming in schools is more and more of an important activity. And it's been labelled as science in certain areas, whether it's a science or not, whether it's an art, whether it's an engineering discipline or it's probably a thing of its own, but it's still a very important subject to teach. But I think that it's not just important to say whether or not we should teach it or whether or not we should engage with it as a society. I think it's also important to spend some time thinking about why and what are the benefits, and not just what are the benefits from a teaching perspective, but what are the benefits for a person learning it? Why would they bother? And I think that, for example, if you look at a guitar, people don't, at least the people I've met, don't tend to pick up a guitar because it's a beautiful object. Well, in many ways it is. They pick up a guitar because they've seen Jimi Hendrix play live, or they've seen Taylor Swift play her guitar, and they've said, that's an amazing thing. What is that? I need one of those. And their friends have said, that's a guitar, and they've got out and bought a guitar. So there's this sort of motivational, aspirational aspect to guitars that really sort of drives people to pick them up, to practice them, to be determined to master them. And they have to spend hours and hours and hours and hours practicing before they can become as good as Taylor Swift or Jimi Hendrix. And so I think in education, we should be thinking of these things too. It's not just we must all to learn to play guitars. It's, well, actually, can we find a way to motivate people that makes it meaningful to them? And I think music obviously has a lot of motivational forces. And so that's clearly explanatory and self-explanatory. But with computer science and computing, I don't think it is. And I don't think necessarily that being the next Bill Gates is necessarily an aspirational desire for a broad spectrum of people, actually. I think we need to find things which are meaningful and interesting to a diverse set of audiences, not just people who happen to be self-interested in programming. I think we need to find ways to broaden that interest. So I think, again, music is a great tool for getting the message out that code is creative, it's expressive, it's a tool that's not just for business, it's a tool for society in general. And we should learn it in schools, not just because governments tell us to, but because actually it can be really deeply meaningful to all of us in many different ways. And I think that meaning doesn't necessarily come from being an app developer. I think it comes from being able to be a normal person, sharing your thoughts and ideas through code. I think, and so with tools that let people do that, I think are quite exciting, certainly for me at least. So all that's introduction. I have show you the website. So this is the website of the tool that I've created. It's completely free and open source, and so you don't need to pay any money to buy it. Let's make this larger picture. It's called Sonic Pi. It runs on Windows, it runs on Mac, and also runs on Raspberry Pi computers. In fact, it's actually installed by default on those. So if you have a Raspberry Pi computer and you've installed the default operating system, chances are you already have the software in your home. And this is really an important part of what I'm doing. Is I talked a little bit about education and teaching, and we've got some articles about education and teaching. But actually, the fundamental part of what I'm trying to do is to try and lower the barrier to entry for creative experiences with code. And so making sure that the learning pathways, how you start, how you get going with code, how you write your first program, needs to be really simple and intuitive and easy. And that's a critical thing. But it's also about lowering those other barriers. So if the amazing tool that someone's developed for education or for learning something is brilliant but super expensive, then that's a barrier, isn't it? So Sonic Pi is free. And then also, if your super whizzy application isn't expensive, and it's simple, but it really requires a massively expensive computer to run, then that's another barrier. So Sonic Pi was designed to run on computers 10, 15 years old. So if you have a computer and it's got a relatively recent operating system, then chances are it's going to run totally fine. So you don't need a fancy Wizzo computer. And even if you don't have one, you can buy a Raspberry Pi for $35 or $40, how much they cost, and plug into TV at home and do everything on this very small, affordable computer. So yes, so the education's a key thing. We've got lots of different things. But let's go back to me. So, but what I'm going to talk about is I'm going to show you an introduction to how to get started. So the website is where you can go and read some information. It's a tutorial. You can click on the link to download the app. You download the app, and when you open it, you'll see something like this. And this hopefully should be a picture of the code.
Zeg Arena has asked, is this just a tool used to learn code, or can it be used for running background music in projects or teaching AI to play music?
That's a very good question. Is this a tool for just learning how to code, or is it? So I think that my guitar example makes sense here to just explain a bit more. That a guitar isn't just a tool for learning how to make music. It's also a tool that once you've learned how to use it, allows you to become a professional musician if you want to be. And so Sonic Pi is designed for both of those things. It's designed to teach you how to program, or to have a first fun, exciting, and meaningful experience and interaction with code that I think is a bit more resonant with people than sorting algorithms or binary arithmetic. But I don't think that I mean, there's a lot of introductory, beginning educational material that just does that. And I think that that's not enough. I think you also need that motivational aspect. You need to have the Jimi Hendrixes of the world showing you what you can do with a guitar to make it an instrument you're going to bother picking up. So Sonic Pi attempts to do the same too. So not only is it something you can teach in schools, and obviously the many thousands and thousands of children all over the world have used this for their learning experiences, it's also a tool which professional musicians have started to pick up and use for their own performances around the world. And so it has to be both, I think. And it has to be a fabulously expressive tool that the artists are going to use to express themselves in new ways, to be that motivational, aspirational tool that motivates people to pick it up in the first place. So yes, the answer is, I mean, at least that's my goal. Whether or not it's a tool that you will be able to use for your own music composition. So that's something you'll have to find out. But I recommend that you try, and I think that it could very well be. And certainly writing your own music, background music, the AI part, you'll have to bring your own AI systems into play, but you can super easy import events from other programs, other systems, other computers, other physical hardware, and use those events to drive the musical interactions. We might touch on that a little bit later, but certainly the tutorials will cover that. So you can definitely take outside programs and use them to drive the music. And so if your outside program happens to have AI built into it, then totally. So if that answers the question. More questions? I think questions are good. I like questions.
Not yet.
Not yet. More questions. Please ask more questions. Okay, right, code. So I think that it's important to make the first program that people ever write as simple as possible. And so in Sonic Pi, when you write your first program, it's usually garbled like this. And when you run it, you get an error, right? So it's quite normal in programming to have errors. Totally fine. All you need to know is that there are some magical words that the programming system understands, and everything else it just doesn't. So this is not a magical word. This is also not a magical word in this system, but it could be in a different system. But in this system, play is a magical word, and it actually requires you to also pass it a number of which note to play. And hopefully you've heard that beep. Does that come through? Yay! So this is a full program. Complete, syntactically correct, semantically correct. It's got all the fancy buzzwords. And for many people who started programming with Sonic Pi, this would be their first program. Although they might not have chosen 70, they may have chosen 80 or 50. Notice that the higher numbers make a higher sound and lower numbers make a lower sound. And that's just a useful property of numbers. Numbers go up and go down. And we use them in programming for all the things that you can count that can go up and go down. And the number of the notes is just one of many things you can use numbers for. So that's what we might call an abstraction. And so here, with just this one line of code, play 50, we're talking about function names. So this play is a function doing something, it's a verb. A number is a parameter to that function. And that parameter is controlling its behavior. So if I said to you, run quickly or run really fast or run as fast as you've ever run, they're parameters to the verb to run. And this parameter 50 is choosing which note to play. Of course, you can write more than one line of code. Let's play 50 and 62. Oh, that's interesting. All right, 50, 62, and 67. How about that? And 82. Ooh. Notice that these are all sounding at the same time. So in Sonic Pi, it's a sequential programming language. So that means that the program runs at the top. That's where it starts, and runs down to the end. That's where it finishes, and does each line one at a time. So it plays 50, then 62, then 67, then 79. But because the computer's so incredibly fast, and also because of the way I've designed the system, more importantly, it actually plays all these notes at the same time. And so what we've got here is a chord. So if you were to strum all the strings of a guitar or hit a bunch of notes of the piano at the same time, you get those sounds at the same time. And so you need to learn one more command if you want to make a melody, which pretty much everyone wants to do straight away, and that's sleep. And I can choose how long to sleep for. So I'm going to sleep for a second between notes 50 and 62, half a second between notes 62 and 67, and then another second between notes 67 and 79. We have a little melody here. Now, what's nice about this is that this is enough for anybody really to get started. And you just need to learn the play command, the sleep command, and know that the number after the play is how high or how low the note is, and the number after the sleep is how long to wait before the next note. And once you've got those two nailed, then you've got basically the fundamentals of Western notation and Western music at your coding fingertips. Because with these two commands, you can reproduce any melody, any Tchaikovsky, any Daft Punk, any nursery rhyme, any Frozen track, just with these two commands. Just by knowing which notes to play and when to play them, you can reproduce any melody. And that to me is pretty exciting. And it gives people that a huge amount of expressive power at their fingertips without really needing to learn much. And already they can start making their own melodies and their own tracks. And I mean, this is important because my niece, who was 6 at the time, she wrote 100 lines of code as her first ever program. And she just kept writing play, sleep, play, sleep, play, sleep. And she was super proud of what she'd written. And when I said to her that was impressive, she said, "Whoa, I've not finished." And she was still typing away like a monster, writing more code. So this is already expressive, but obviously, when I say that you can use this to perform in music festivals, and artists, professional musicians are using this, they're clearly doing much more than these beeps. And I think that's really important to understand, that you can start here, but there's a long, long, long way to go in terms of what you can do. So in the remainder of the time left, I'm going to quickly whiz through some things you can do. But I wanted to spend a bit of time at the start of the talk just really introducing the motivations and also showing how simple it is to actually just get started. And I think that's really important. I think computer systems that are complicated are probably badly designed. I think that actually it does take a lot of effort, but making systems simple is often possible. And when things are complicated, it often feels like, or hard to understand, it often feels like it's your problem. I'm not clever enough to understand the system. And that's actually not always the case. It's probably the person who wrote it wasn't clever enough or didn't put enough time in to make it simple for you. So please, my promise to you is that I put a lot of effort into trying to make Sonic Pi simple. And so please give it a try. And if any of it isn't, let me know so I can try and fix it. What would be really useful for you to know is that when you press the help button up here, you have a full tutorial built into the application, which will teach you everything you need to know to get to be a very proficient Sonic Pi coder, educator, performer. And so that tutorial is written assuming you know absolutely nothing about code or music. So you can learn both at the same time. And if you obviously have some programming skills, great, you can use them and apply them. If you have some music skills, great, you can use them and apply them. But you don't need to have any sort of formal music theory training or programming training to get started. That's really important to know. And then everything I'm going to show you from this point on, I don't expect you to understand. In the same way that if you go and watch an ice skater ice skate, you can understand that they're standing on the ice, they're balancing, they're sort of moving forwards. But when they're doing their fancy pirouettes and jumps, you probably don't understand how they do that. But you know that it's possible, that you know that if you practiced, you could do that too. So this is the rest of this talk really is showing you what's possible. I don't expect you to necessarily understand it, but I do hope that you trust me in knowing that everything I'm going to show you is simple enough for me to have taught a 10-year-old child. So the only barrier between where you are now and what I'm going to show you is just practice and patience and sitting and learning and opening your mind and getting involved. And it's not something that should be rocket science or brain surgery or those analogies people use to make you try and sound clever. It's really, if this isn't simple, then I've not done my job properly, and I'm sorry, and I'll try my best to fix it.
So I have another question for you from our YouTube chat, which is, can you use music notation notes like C or C sharp, or instead of the numbers? How do you do the numbers?
Screen there. So I've got play E1, if you can see that. I think actually that's a really important question. All right, so let's just go back to play 60. What on earth is the units of 60? What does 60 mean? If you understand some of Western notation, what on earth is that? I think that the basic answer to this is that you don't need to know. And having a Western theory background and knowing what C sharp is and E flat is and all that kind of stuff It's nice and useful, but it's not necessary. And really all that's important is that if you don't like that note, did you want a higher note or a lower note? And choose a high number or a low number. But if you have some understanding of Western notation, you might understand this is working on what's called a chromatic scale. So this is actually playing all the notes of a piano. And if we were to like number each note in the piano, including the black notes, then each successive integer up is the next note on the piano. So this is piano notation almost, tuned like a piano. So that's equal tempo tuning. So you take an octave and divide it by the 12 notes in an octave. But it's important to point out that this is not necessary to understand. But if you do know this, you can actually just write in the notes that you want. So E octave 3, E octave 2, C sharp octave 2. So that you are able to work with Western notation if you want to. But I never really start with this because I think it's a barrier to entry for lots of people. It's sort of saying to people, you need to understand what CS5 means to use Sonic Pi, and you don't. But if you do know what that means and it's useful to you and it's meaningful to you, you can also bring that knowledge in. You can also do weird things like this, right? This won't mean anything to anybody. What does CS5 plus 0.1 mean? Well, actually, that's bringing the tuning up. So you could actually work with any pitch. This is actually playing a note in between notes on a piano. It's a bit like a guitar when you bend the strings. So you do have access to any note that you can perceive and hear. You can either use the straight up numbers, which is MIDI notation, or you can use floating point numbers to give you access to the full spectrum of the different notes, or you can use Western style notation, where you put a colon, the name of the note, whether it's sharp S or flat B, and then the octave of the notes, and you can directly do that. So is that your answer?
That's epic. You thought of everything.
Yeah, oh yes, I spent a lot of time thinking about this.
Man, you have love as your response from
good,
the chat.
good.
Thank you. One more question. So Harry says, sleep function without importing time shows that it's simple. Can you use Sonic Pi as a module with other languages like Python?
Can you use Sonic Pi with other languages like Python? So Sonic Pi is really a standalone app. That's the way to see it. And not really as a language, although it has a language integrated. And actually Sonic Pi is built on top of a language called Ruby. And you can use a lot of the Ruby functionality if you want to, but it's not supported because it's very hard to support a full language and supports the full kind of things you would do with a generic programming language. Like you wouldn't want to use Sonic Pi to build a web server, although you possibly could use the Ruby stuff inside of it to do that, but that's not a necessarily good idea. So you're going to see Sonic Pi as an app, and it's an app specifically for making music. And so it's, as an app, its inputs and outputs, I guess, are the things you need to talk about in terms of working with the programming languages and programming systems. And so the inputs and outputs of Sonic Pi are obviously audio. So if your programming system can work with audio streams in your operating system, then that's fine. And Sonic Pi can output audio onto multiple channels. It can read your audio in from multiple channels. It can also output and input a type of event called MIDI. And MIDI is a musical event system for connecting hardware interfaces together. So it was designed when you might have had one box which had lots of different sounds, and you had lots of, well, actually no, it's the other way around. You would have lots of keyboards, all with their own distinct voices. And then you would have one keyboard, which would be your controller keyboard, and you'd be able to switch between controlling that keyboard or this keyboard or this keyboard or this keyboard. And they would have wires connected to them, and they would talk to each other via this thing called MIDI. And that's weird because that's a protocol from the 70s, which is still in every single operating system. Even your web browser has MIDI capability. So MIDI is amazing. And MIDI lets me, like I can play my keyboard here, and on the right-hand side of the app, you should be able to see those MIDI events coming in. Here we are, the sub-fatty note on, note off events. So you can work with those events. You can bring those MIDI events into Sonic Pi. You can export them out to other applications. And then also there's something called Open Sound Control, which is a networking protocol which runs over UDP over the Ethernet connection or the Wi-Fi. The Wi-Fi you probably should tend to try and avoid. And that lets you talk between applications as well, and across computers. So if your Python system, if you import an open sound control library or a MIDI library, or you work directly with some sort of system that can do audio, then you can interact with Sonic Pi. Hopefully that answers the question.
Awesome. Thank you.
Yeah. Cool. Any more questions?
None as yet. So
None as yet. Cool.
Show us, Sam, what have you got for us now?
Right, so we haven't even got past play and sleep, which is pretty cool. Right, so this as an educator, I think this is really interesting because we've spent a lot of time talking. We could clearly spend a lot more time talking about lots of interesting things, and we've only got 1 or 2 lines of code on the screen. So it doesn't have to be complicated to start to expose all these interesting things, which are really interesting things to talk about. Let's quickly go ahead. And so if I do E1, for example, that's quite a low note. I can make that last for 8 seconds. If you haven't got very good headphones, you might not be able to hear that. If you're in this cinema, so those of you at home with cinema speakers, your subwoofers are probably shaking. Actually, I did do some talks in cinemas around the world. The best was in the Netherlands, and yeah, this program here, when you make it really loud, shakes the whole room, the whole subwoofer, like for the explosions of Star Wars. So that's pretty fun. But let's introduce another piece of code. This is called use synth. This allows us to change the sound. I'm going to change it to the Prophet sound. That's a much more crunchy sound. And so we can change the cutoff of this. What on earth is cutoff, I hear you ask? Well, different numbers change the crunchiness of the sound. So we already started to hear that we don't just have to do beeps, we can do much more sophisticated sounds, and we have a lot of control over those sounds. So this particular sound, the Prophet sound, is actually based off a analog synthesizer, has many controls inside Sonic Pi. Cutoff and release are 2 of those. And as you learn sort of the vocabulary of those synthesizers and what these weird words mean, and these are weird words, these are words from the synthesizer world. My synthesizers have those words written on them on their knobs. And here, they're words as a parameter to the function. But they're optional, which means that you don't need to write them for it still to work, but if you do write them, it can give you more expression and more ability to control. So this is a key aspect of Sonic Pi, that as you need to do more sophisticated things musically, you will need to write more sophisticated code. You can't really escape that. And so it's about learning what these words are. And you can look these up. There's documentation for everything. So if you don't know what release means, that's fine. Just read the tutorial, it'll tell you. And the same for cutoff. It'll read the tutorial, it'll tell you. And also just experiment. Like put a ridiculously large number in and see what happens. And in this case, Sonic Pi knows that number won't work, so it doesn't let you run the code. And it lets you know to say, hey, that cutoff value must be less than 131. And your 3 bajillion million universes of numbers is too high. So let's go back to 130, and we have our noise again. What also is interesting to me, and maybe to some existing programmers out there, is that can you hear the sounds overlapping each other? So every time I press the run button, the screen goes pink. And what that does is it creates kind of like a magical musician inside the computer and gives that musician the code on the screen to execute, to run through as her script. And so she starts at the top and says, okay, I need to play with the Prophet synthesizer. Next line is blank, ignore that. Next line is play note E1 for 8 seconds with the cutoff set to 100. So she hits that note, and when that note finishes, poof, disappears. And so this is what's happening when I run this code. So the person's been magically created, they're playing that sound, and when that sound finishes, then they disappear. But of course we can have more than one person, magical people in our system. And these are all working at the same time. And when they've completed their activities, they all disappear. So what we have is what's called a multi-threaded environment. It's a system where multiple things can run simultaneously and exist in the same time space. And that sounds, I mean, as if you're a programmer, that sounds terrifying. like you don't learn this kind of programming until university level. That's an advanced style of programming. But in music, it's absolutely the sensible option. It's actually much more of a crazy idea to have a one-person band where that one person is trying to play the guitars and sing and the drums and they're all over the place contorted, versus having separate people, a separate singer, a separate bass player, a separate guitarist, a separate drummer. That's just a way easier way of making that complicated sound. So concurrency, multiple things happening at the same time, is actually really natural in the musical environment. And so actually Sonic Pi, trying to be a tool for music, has to also make concurrency natural too. And so this is what you're seeing here. Hopefully you're not seeing any complicated code. You're just hearing that every time I press the run button, it's just playing the sounds on top of the other sounds, and that's natural. So we'll see another example of concurrency in a moment, which really makes things exciting. But know that concurrency is not hard. It's not something that 10-year-old children struggle with. It's very obvious. The hard parts of concurrency, the things that people get scared about, and I don't want to go too technical at the moment, but they don't really exist in Sonic Pi. I've removed most of them or sort of pushed them to the corners. So things like mutable state and sharing data across threads and coordination of threads, those are all things you do not need to think about when you work with Sonic Pi and threads. So that's, hopefully that makes it much easier. Okay, so where else can we go? So we had the ability to do notes, to wait between notes. I promised you that the timing is super accurate, so you can do really sophisticated timing stuff. So you have access to making any melodies. You can change the sound with the YOW synth, and there's a whole bunch of different sounds to work with. These are all almost like different synthesizers. So each time you use YOW synth, you're creating a new physical synthesizer to play with, and there are many of them built in. And then you can control those synthesizers with the parameters. You saw the cutoff and release. And these are like knobs on my synthesizer that can control the sounds. So that gives you a lot of power already. There's two more major things to look at in terms of modifying sounds. Let's look at one of them first. But actually, before we do that, let's look at control structures. I can do something 7 times. I can play note E3 with a release time of short and C for short amount of time, 7 times. 1, 2, 3, 4, 5, 6, 7. That's pretty cool. Or I can actually play from a data structure. Let's make a data structure which is E1 minor pentatonic and choose a random note from there. Let's slide this across so you can see the screen. There we are. That's very low. Let's make it higher. So this thing here, scale E4 minor pentatonic, is just a list of notes. It's just Western theory. Musicians have all sort of decided that there are a bunch of notes that sound nice together. They're given those kind of groups of notes names. They're called scales. If you've ever done any website work and you've worked with a website designer, the designer's come to you and said, here is the color palette for this site. We're going to only use these colors. This red, this particular green, this particular yellow, and this shade of grey. And that's it. So you can only use those colors. And if you do, then everything's going to work nice. And so these scales are kind of like color palettes for notes. Other people have decided they sound good together. You don't have to think about that. Just choose one of the scales, different color palettes, different things. Minor pentatonic scale, it's got a fancy name, but it just always sounds quite nice. So it's a good one to go for. Now, so we've got this iteration, doing this 7 times. Obviously I can do this 14 times. Lovely. But what I'm showing you now is that we have this idea of blocks of code, chunks. Have you ever done any programming with Scratch, for example? Really nice programming environment. This looks like a Scratch block, and this is the code inside the block, and this is the outside piece here. And we use blocks quite a lot in Sonic Pi. We've used them here for iteration. I'm going to write another block of code here. And this block I'm going to use to create an effect. So I'm going to modify how the sound sounds. What on earth does that mean? Well, if I am a guitarist, I might buy a little box which makes my guitar sound like it's in a massive room. And I might buy another little box which makes my guitar sound really distorted. Or I might buy another little box which makes my guitar sound like it's got an echo. And then I might plug my guitar through those boxes into the amplifier and then change the controls of those boxes to really modify the sound. Well, we have exactly the same of that in Sonic Pi. It's called an effect. So if I say with effects reverb and use like the room size 1 to make it sound like it's in a huge room, we now have this nice reverberating effect. Or if I were to choose a different effect like Bit Crusher, sounds more crunchy, or crush, or echo. So you can see how I can modify the sound as it's coming through these effects. So that's a really important thing to learn about, is effects, and there's many of them. You can combine them, so I can have echo and reverb and flanger and distortion. That's a lot of fun. And then another thing to learn, the final thing really, is sample. So far, all the sounds, all the synthesizers, and all the effects are actually generated inside the computer using fancy mathematics. So there's lots of techniques to use to do funky stuff with the numbers to figure out where the speakers essentially need to move to generate those sounds. That's awesome. It gives you a lot of power when you're working with the mathematics, because you can really control those functions and control in a very fine, detailed way how the sound is produced. But another way of working with sounds, which perhaps is a lot more intuitive, is to actually just record the sound. Take your phone or a recording device and just with a microphone and record the sound and then play that sound back. And so that gives you the ability to reproduce the sound of anything you can hear. So tree falling down, train going past, someone playing the saxophone, somebody singing, whatever you want. And Sonic Pi has a bunch of built-in samples which help you to get started and are really useful for giving workshops. But you can totally use whatever sample you've recorded yourself or downloaded from the internet or bought from your favorite artist who might have released a sample pack. And so you can bring in all those sounds. And when I do my performances, I'm using a lot of sounds that I've bought, that I have the license to work with, in addition to the built-in synthesizers. So they're available via sample. Let's look at this arm end break. Play it loud. So that's the sound of somebody hitting the drums, right? So that was actually recorded in 1962 or something, 64. And that sound is still being preserved by essentially storing the data values of where the air particles moved after the drums were being hit. It's pretty crazy. But we can work with a sample. So I can actually play at half speed. This is exactly how one of the tracks Straight Outta Compton by NWA used this exact sample, and Dr. Dre was rapping on top. And then a few years later, mid-90s, this kind of music came out, and that's the same sample played faster. You can go really crazy, like whatever you want. Or we can do something like this, rate -1. What do you think that does? Backwards. And we could also do fun things, right? So once we've got a computer inside our system, we can get the computer to do things really quickly that we would struggle to do ourselves. And one of those things that happens a lot, certainly in the early days of music, is people, well, to say the early days, I mean like 80s, with this kind of style of computer-made music and sampling. Musicians would take a sample like that and use magic audio scissors to chop that sample up to get each individual drum out, that drum break. And then a bit like you might take a newspaper and chop up all the words and then rearrange them to make a letter that's completely different, or a new article from the news which didn't match what the original was. Maybe the original article was about cuddly teddy bears, and you've used the same words to make an article about park benches. I don't know. Somehow you managed to do this. So we can do the same with this code. So we can get the computer to actually analyze that data that is in the sample and to do the magic scissors things for us, and then let us work with this thing called an onset, which lets us use a number to pick out every single drum. And that's nice because I can use this iteration technique and play that drum set 5 times or 8 times. Or I can play onset 12. Or I can play onset pick. What does that do? Well, what that does is it actually gives me a random drum in that sample. That's quite nice. That's reorganize the drums in a completely different way. And so I can create a loop here, and I can now play it round and round and round. We don't even need that. We don't even need that iteration because it's just looping round and round and round. So this is fun, right? What I found quite interesting is, let's just comment that out. So that means the code is ignored by the computer. Now, in the early lessons I did in schools, because this system was designed within the classrooms, watching and observing students using it and using those observations to feed back and to improve the design. What I saw very early on was when someone had learned how to do a loop like that, they would go, cool, got the drums. Right, I need a kick drum. And so they would do something like this, and they would do something like this, and they've got that kick drum sound, bang, bang, there we are, great. And so what they would then do is that they would then write this code. Now, I think this is really interesting because it gives the opportunity to talk about how you learn how to do, how to be really good at Sonic Pi. How to be really good at Sonic Pi is really about writing the code first and then not pressing the run button, but looking at the code and trying to imagine what it might sound like. And that's actually quite hard. It gets easier the more times you do it. So let's look at this. We've got 2 loops. One's playing the kick drum and one's doing the random drums from our arm end break. And we heard how they sounded independently, but let's hear how they sound together. So imagine it in your head. Let's run the code. Oh, I'm only hearing the kick drum here. And this is what I found all the time in the classes, that you'd have this child would put their hand up and saying, "Sir, miss, my bass isn't happening at the same time as my drums." It's like, yes, that's a question we need in the computer science lesson. Great, let's fix this. And so you look at their code, and they've got 2 loops, which makes complete sense because you've taught them the loop spin something around forever, and they've got 1 drum and they've got 1 random other thing. They want to play them together. But of course, in traditional programming languages, sequential programming languages, what tends to happen, and this is true for most of them, is they start at the top and work their way down, right? So we start at the top and we have this loop. The loop says do something forever. We're going to play their kick drum. We're going to wait for half a second, and we're going to loop around. And so the code stays inside that loop at the top and never, ever gets down to the bottom here. And that's a problem. So this poor child has got their hand up, and you say to them, sorry, it's impossible. And they say, well, what do you mean? Well, you can't have 2 loops at the same time, because the way the program works is it gets inside that first loop and stays there. And they say, well, no, I want my drums at the same time as the bass, sir. How do I do that? And so I remember early on talking to the teacher and saying to the teacher, we need to teach them how to play the drums at the same time as the bass. Can we do that? And the teacher said to me, sounds great. What do we need? And I said to the teacher, we need to teach them threads, how to do multiple things at the same time. We talked about this earlier when we talked about bands. And we want a band that has more than 1 person in it. Can we do that? And the teacher said to me, that sounds awesome. Is it on the curriculum? I'm looking at the curriculum, and it's got like conditionals and functions and sequential programming and parameters and abstractions and data structures, all the things we've been explaining so far with the basics of Sonic Pi, you can totally do. But threads is not on the curriculum. And so when I said to the teacher that I didn't see it on the curriculum, they said, well, sorry, we can't teach it. And so I said to the child, I'm sorry, you've got to wait till university. This poor child just looked out the window and was not interested. So I was like, okay, we need to sort this out. How do we fix this? How do we cheat? How do we sneak in this idea of drums at the same time as bass, and the way that the teacher doesn't realize it's not on the curriculum, but also allows them to teach the core curriculum thing. So clearly loops are a core curriculum thing to teach. It's a good programming structure. It's simple. It's a nice thing to teach. And so inside Sonic Pi, what we have is we don't ever use the loop. We have a live loop. And so we just change the name. And live loops need to have one more thing. They need to have a name. So I've got my two band members. Kate, she's playing the kick drum, and Sarah's playing the arm and break drums. And so we can give our live loops any names we want. We can give them descriptive names to do with the music. So this could be like kick, or this could be break beats, or we can use names of people, whatever we want, as long as they're all unique. That's what matters. So we can't have two Kates in this band. That's not allowed. Everyone has to have their own name. Otherwise the computer gets confused. Now if I run the code now, you can hear them playing at the same time, which is huge fun. So in Sonic Pi, you teach the live loop for loops. Like, it means you can teach loops, but also means that the kids and whoever's using it can do what they actually naturally want to do, which is play the drums at the same time as the bass. One more thing, which actually is pretty cool, which also is not on the curriculum, but actually everyone tends to want to do, is that maybe that's too loud. I can't quite hear myself. So make it a bit quieter, right? And make this kick drum have a lower cutoff. Or maybe I want to comment this out, have a kick drum going, and then bring this back in again. Or maybe I want to change this sample to something completely different. And so the live loops, they let us modify the code as it's running, which opens a brand new door to programming. So far, up to this point, I've been using Sonic Pi very traditionally as a programmer, where if you speak to any professional programmer, they'll all tell you pretty much that their workflow, they'll use fancy words, they use the latest buzzwords and the latest practices and methodologies and whatever. I'm not going to even use any, but they'll use whatever the latest trendy thing is. But really, all programmers go through the cycle where they think a bit, they write some code out a bit, they observe its behavior somehow, they test it, they watch it run, they run some theorem provers, they run their compiler, whatever they're doing, they observe it, they see it's not what they want, it's never what they want, and then they go back. They reset everything, they think a bit more, they write a bit, change the code a bit, maybe they add a bit of code, maybe they delete a bit of code, then they observe it. And then they keep that cycle until it's good, and then they send it to the world. They git commits or whatever they're doing with their code to share it. But essentially, you're in this loop where you're thinking, you're writing, you're observing, and then you start again. And so every time you start again, typically you tear down the whole program, you delete everything that was in memory, and you try again. And you try again with a clean slate every time. What we're doing here is not that. What we're doing here is we're having a program which is running, and instead of tearing the whole thing down because can you imagine that? Can you imagine a performance where we're like, yes, it's cool. I'm gonna make some drums happen. Everyone, stop dancing, right? Stop dancing. I'm going to change the code. I'm going to change it back to this loop. That'll be a rubbish performance to watch, right? Let's go back to loop. Let's go for a loop break bit. Right, where I'm changing the code. So if every time I wanted to modify the code, I had to stop it and then restart it, that would not be a good performance. And so music really asks different questions of programming environments and programming languages and programming systems than many current business contexts ask. I think that's actually quite an exciting thing, and it gives a really, really interesting environment to do research, to ask new kinds of questions, and to push our programming systems in new directions. So things like time, for example, are things that programming languages don't typically tend to really focus on. They tend to focus on order and throughput. And so I want to make sure that my computation happens, I get the same results, but if I have a faster computer, I want to get my result faster. That's ideal. If I run my Photoshop plugin, I want to see that color fix happen quicker when I bought my new PC than with my old PC. But with music, if I buy my new PC, I do not want my music to go faster. You can imagine, like in 10 years' time, all the music will be like, right? So music makes you think differently about the kinds of requirements you might have with your programming environment and system. So that's quite exciting as well. So we have threads, we have live coding, and these are all things, hopefully, you can start, you might not understand what this is, and it might look a bit weird, but it shouldn't be that complicated. At least there's only 8 lines of code. So 8 lines of code there. And if you were to, I promise to you, if you were to spend an hour thinking about it carefully, it will start to click in your brain. You'll make sense of it. So, and then once it clicks, then you can start to think, ooh, what could I do with this? What would be my samples to use? What would be my synthesizers to use? Which effects would I use? How long will I think for between each note? Or how loud will I make it? And I think that's really exciting. And when you go into a classroom and you teach people the basics of Sonic Pi, and then you let them play, you'll be amazed about how every student's work is completely different. And that's really fabulous. So they really are taking it in their own direction. And that's something that you can do too. So when I'm about to do a demonstration of what you can do with this, when you watch that demonstration, just know that that's my music, you know. And if you were to use Sonic Pi, you could make completely different music that you like. There's a lady, it was a few years ago now, she emailed me from Canada, and she'd used Sonic Pi to notate an opera. And there's a lady in India, she was making traditional tabla drums and India music and singing over the top. There's a guy from Finland who's been making ridiculously heavy metal thrash music. So you can really, I mean, obviously you could bring in your own samples, whatever sounds you want, add your own effects in crazy ways. You can also, I'm not going to spend any time talking about this, but you can use Sonic Pi as a full music studio production tool. So you can work with audio from synthesizers like this. You can control these synthesizers using MIDI and modify them. And so you can work, for example, if you've got a school and you've got a talent competition and there's loads of entries which are basically the standard bands with a guitarist, a singer, and a bassist and a drummer, you could enter that competition as a live coding band. So you could have somebody coding the beats and also bringing in the drums or the guitar and modifying the effects, adding reverb, adding distortion, all live, and also a microphone as well. And just with an extra couple of lines of code, you can create a live coding band. And I think that's quite exciting to think. And I'm pretty sure a live coding band's going to fare a lot better than another standard guitar band that everyone's seen 1,000 times. So I think that's also quite exciting as well. Yeah, shall I show you what you can do with this then? Is that
I would love that.
So what I do when I perform, I have this file here, and this file has a list of names. So in Sonic Pi, you can pass a directory which has a bunch of samples. So I can have a directory of beats, a directory of bass loops, a directory of guitar riffs, a directory of vocals. And here I've got lots of these directories, and I've given them all names so that I don't have to remember this full list here. I can just type in sample, and then I just need to remember, what was it? It was E-bit, bass, that's the bit I need to remember. And then inside that directory, there's lots of samples, and I'm going to find one of there which has 120 in the sample name and CM in the sample name. So this just lets me search inside that directory. And now I have, I need to run this code first. Ability to play a sample. So this is not a sample built inside Sonic Pi. It's a sample I've downloaded. It's actually a sample directory, so there's many samples. And I can work through those samples. I can play the next one. So I can do that, and I can also do another sample E-bit beat. And I'm going to find, I'm just going to choose the fourth one of those. We start counting at 0. Now beat stretch that to 8. So now I have two samples. I have a drum sample and a bass sample. But it stops. So, but what we have here now is that it's important to point out that for everyone watching is that those samples are just pre-recorded sounds which I downloaded from a sample pack from the internet. You can download your own, and they could be any style that you wanted. So if you wanted jazz or rock or drum and bass or whatever the latest cool technical name for music is, there will be sample packs for those, and you could plug them into this. So you don't have to listen to this music, you can listen to whatever you want. But of course, we need one more thing if we want to make this into a performance, and we need the live loop. So let's give this a name: beats, do, end. Now I've run this code. You notice that we have an error. This is important, so we always make mistakes. So in Sonic Pi, making mistakes is acceptable. That's totally a normal thing. But when you're performing, what's not typically acceptable is the music goes quiet, right? So we need to not do that. So what's happened here is our live loop doesn't have a sleep command. And that without the sleep, you're asking the live loop to spin round an infinite number of times in 0 time, which is clearly impossible. And the computer, most programming languages will try to do that and just burn the computer down. Sonic Pi sees you trying to do that and goes, nope, won't even attempt that. So what you also need when you're doing a performance is 2 live loops at least. Always have more than 1 live loop, because if I have an error here and I have my bass drum live loop, and I've got my kick drum. Now I've got my kick drum in the background. We've got the normal drums going around, but there's an error in the beats. But the kick drum is still happening, right? So this is okay. So when you're performing and this happens, which happens all the time, the audience think, they've brought it down just for the kick, just to get us going again, right? So you want to be able to bring it back in. So yeah, and Michelle's off you're going. So if I synchronize this live loop with the bass drum live loop and fix the code, I can bring it back in. So this is a critical thing to know about live coding, is that you can, with multiple live loops, you have the reliability to make sure that if things break, you can always fix them. Right, let's go into performance mode. So what I need to do over here is to switch to crazy discos. Right, actually, I'll turn my microphone off just for the duration of this. I've no idea what happened then. So the screen sharing stopped and I was on mute.
We'll just have to see you playing live, hopefully, sometime in Australia in the not too distant...
That'll be amazing, yeah.
Not too distant future. Because I know we have enjoyed many fine little mini concerts from you down here, and much appreciated. I don't see any more questions, but I hope everybody watching has very much enjoyed. Thank you so much for getting up at some horrible hour. I don't even know if the sun's up for you yet. But
well, if you do have any more questions, then obviously the YOW people, Michelle particularly, are definitely worth asking because they can forward things on to me. But also there's a really nice forums that we have that you can ask. It's full of artists, it's full of teachers, it's full of musicians that can all help you and get you started. So if you're interested in doing anything I've shown so far, then there's a really nice community of people that are also doing that would love to help you and to push you over that getting started barrier, because I think it's quite a difficult thing for many people. I think also from a musical perspective, I think it's really interesting to open up what electronic music is and to show the processes that could be used to make it. And so when you're projecting the code, you get to see what the musician's doing. And also by doing things live, you do get to be in that position where things go wrong. And I think that's I'd much rather go and see the gig where Dave Grohl broke his leg, for example, and then came back an hour later and finished off the gig. That'd be way more memorable than watching a band press play on a CD and just dance to their own music and not actually produce it live.
Sonic-pi.net. Be there or be square. Download it, play with it. It is free. And Sam has a Patreon if you've enjoyed this little tutorial and concert, or if you like the software, you can use that to help support Sam's awesome work. Thank you everybody out there in YouTube land for tuning in, and those watching on the recording. And yeah, cheers. We'll catch you all later.
Bye.